How do you go from messy output to perfectly aligned text in Python? This right here is beautifully formatted. We have a variable holding a list of programming languages. Each language name has a different character count. Go is only 2 characters, while Python is 6. Java is 4. Now if we simply print this using a standard for loop, looping through each language in the list, we just iterate through them all. And for each language, we print its name to the console. So this is what the output looks like. The first entry is Python, so Python gets printed. Right next to it sits a pipe symbol followed by the word install, but we want this to be aligned. How do we quickly align text in Python? Here's the trick. Normally, placeholders look like this, completely empty. Just empty curly braces. But the moment you add a colon inside and then a number after it, say 10, Python will pad the output with spaces wherever characters are missing. So for Python, which already has 6 characters, Python will add an extra 4 spaces, bringing the total up to 10 characters. The same applies to Go. Because it is so short, the remaining width gets padded out with empty space characters, and you can keep adjusting this. For example, if you drop it down to 5, you will see the output becomes misaligned because Python is 6. The longest name is 6 characters long. Set it to 6, and everything snaps into alignment with the longest entry. If we drop it to 5, it falls out of alignment because of that character difference. But set it to 6, and everything lines up neatly against the Python entry. Want even more padding? Go with 15. There is no upper limit. You could go up to 50 if you wanted. It honestly does not matter. Just use the format specifier. Add a colon, then specify the total character width you need. That is all there is to it. Here is a common challenge that trips up many developers. How do you tell apart space characters from tab characters in Python? To solve this, we are going to use Python's string formatting. Here we have the dot format method in action. It can accept a variable, but here we have hard-coded the word Python. Using the formatting syntax, we can control the output with a colon. Everything before the colon represents the value being passed in. In this case, that value is the word Python, and everything after the colon defines how to format it. Here we are saying, format it with 10 spaces. You can use 5, 9, 10, 20, 99, whatever you like. 9,999 is just the number of spaces to add. For this demo, let us go with 10. When we print this, notice we are wrapping it inside the repr function, right? Repr stands for representation. When you use it, it reveals that this is a string. It wraps the output in quotation marks. Without repr, you just see the text with no clear boundaries. You cannot tell where it starts or where it ends. But add the repr function, the representation function, and you will see quotation marks wrapping the entire string. And inside those quotation marks, you can count each individual space character clearly. Watch as I move along the string. You can see each character highlighted one at a time, step by step. Now let us try a tab character. When we take the repr representation of this string, \t is the escape sequence for a tab, and in the output you can see it printed as \t. Without repr, it just shows something invisible in the output, and you have no idea whether it is a space or something else, right? So if we were to add another tab character here, now we have 2 tab characters sitting right there, right? You can clearly see that. But wrap it with the repr function, and suddenly it becomes crystal clear. There are 2 special characters there. With repr, spaces appear as spaces inside the quoted string, and any special character like a tab will appear as its escape sequence \t right here. But without repr, you are left guessing. As I highlight this, you can see something is there. But what exactly is it? Moving along, there is something there, something there. You can see the cursor jump, but you cannot identify it. Without repr, you simply cannot confirm whether it is a space or not. Now, if we do have a space in here, and we wrap it with the repr function and run this again, you can see there is a space character sitting right between the 2 tabs. This is how you identify them precisely. Use repr, and for spaces, they will appear as literal spaces inside the quotation marks. And for anything that is not a space, it will show you the exact escape sequence. Do you know how this code achieves left alignment and right alignment of text in Python? This is an essential skill every developer needs. Let us look at the output first, before I walk you through the code. In your console, you often need to print out structured data or display it neatly in a user interface. You want the text aligned like this, where items are on the left and the quantity sold is neatly on the right. In Python, if you remove all the formatters and strip everything out, this is what your output looks like without any formatting. Without any formatting, this is exactly what you get. You can see it does not look great at all. So let me break down how this code works right from the beginning. Notice these empty curly braces here. The dot format function is called directly on the string. Inside the string, we have placeholders. What we want is to inject these two values into the output. It loops through this list right here. Inside that list, we have tuples. Tuples are represented by these round parentheses. Each tuple holds a product name and the units sold. Those values are then stored in variables, which are then passed into the format function. The format function then places each value into its matching placeholder. So the name goes here, and the units sold goes here, and you end up with output like this. But you can format this. You format it by adding a colon inside the placeholder, a colon for the name and a colon for the price, but running it like this has no effect yet. After the colon, you define the format. Before the colon is the item itself. That would be the product name. And over here would be the number sold. After the colon is where the formatting lives. We can tell Python that each product name, like keyboard or mouse, should be padded out to exactly 12 characters in total length. When you do that, you get this kind of output. Now, it is already looking much cleaner, but the price column still looks a little off. So we can also set the price to a fixed width of, say, 6 characters. And when you run it now, look how neatly the text aligns. Numbers are right aligned, and text is left aligned. Perfect structure. This is Python's default behavior. Text aligns to the left, numbers align to the right. Python assumes that right-aligned numbers are easier to read, and left-aligned text is easier to scan. So you do not actually need to specify left alignment for text or add a right arrow for numbers. Python handles it automatically, right? Now watch what happens if I change that to left alignment. If I change to left, you can see all the numbers are now left aligned. They read 125, 32, 1050. But I can right align them by switching the arrow to point towards the right. And there you go. Now they are right aligned. You can do the same with text too. For example, text like in stock or out of stock. See that? Right aligned. By default, without any arrow, text is always left aligned. But you can override that default behavior and force a completely different alignment. You can right align text so that it looks exactly like this. I just wanted to share this powerful technique for formatting strings in Python using the dot format function together with string placeholders. Mastering output formatting in Python is an incredibly powerful skill. Take a look at this beautifully formatted main menu section right here, and also this section with the word scores perfectly centered as a title. This is surprisingly simple to do in Python. Let us walk through the code so you fully understand it. The key to understanding this code is recognizing that we are working with a string. This string sits inside quotation marks inside the print statement. So inside the print function, you have a string. Now that string, notice it opens with a quotation mark and also closes with a quotation mark. But inside it, you will see something unusual, curly braces acting as a placeholder. And outside the string, you will see the format function being called. So you might be wondering, what is actually happening here? Inside the format function, you can pass in any variable. In this example, I have actually hard-coded the text that I want to display in this centered format. So this first line, if I pull it out, it will use this hard-coded text. But remember, this could just as easily come from a variable. If you're pulling a value from a database, for example, you can put the variable name in here instead, without the quotation marks, of course. What you end up with is a placeholder. This curly brace section acts as a placeholder. It takes whatever value you pass in and injects it right into that placeholder position. But the placeholder also has some powerful options built in, giving you control over formatting. You activate those options by adding a colon and then specifying whatever formatting you want to apply. In this case, by using the caret symbol, which looks like a little hat, also known as the circumflex, you can tell Python that this entire string should be 30 characters wide, and your text should appear centered within those 30 characters, right in the middle. This is the key insight. You told Python you want 30 characters total, and the caret symbol does the heavy lifting. Its job is to center your text. Now, remove the caret symbol and you will see the text main menu just appears, followed by 30 trailing spaces. But the moment you add the caret symbol back, it centers your text within that total width. That total width of 30 characters includes your text itself. So if your text is longer, there will naturally be fewer padding spaces, but it will always be centered automatically. You never have to manually calculate where to center it. On the next line, I'm simply printing a new line character to create a blank line. So there's a line break here. There's an empty line here, but I could easily remove it. And you can see the output now sits right below the main menu. Then you have this row, which is 30 dashes. Because you know the total width is 30, you can add exactly 30 dashes. So if I change that to 40, you can see it extends to 40 characters, but the text is no longer centered. To recenter it, just update both values to 40 as well. Now, main menu is perfectly centered within those 40 dashes. And you can apply the same idea to other sections. You can achieve a stylish look like this by multiplying the equals sign by 30, and then placing your text in the middle, like the word scores, perfectly centered. Beautiful. Notice that scores is a different length than main menu, yet Python automatically calculates the center point and places your text there just by using the caret symbol. And then the equal signs appear on both sides. Just remember, the format function will take whatever you pass in. Here I am using a variable, as you can see. Whatever value that variable holds, format will inject it into the placeholder inside the curly braces. And then the formatting is defined after the colon. Always remember to include that colon. After it, you specify the exact formatting you want. Now, if you just use 30 without the caret, it will not center the text. All it does is pad the output with empty spaces after the text. You can see them there. But add the caret and watch, it centers perfectly. I hope you discovered something exciting and useful in Python today. If you did, please like, comment, follow, and subscribe. It really helps this channel grow and motivates me to keep creating more videos. You have probably seen this Python syntax and wondered what on earth it does. This is the dot format method, the string formatting function in Python. If you hover over it, you can confirm it is a method that belongs to the string class. Here we have a string wrapped in double quotation marks. And what we want to do is format it in a very specific way. We want to print a series of invoice numbers. Let us run this code and see what happens. Here we get invoice number 1, 2, 3, all the way up to invoice number 1999. Almost 2,000 invoice numbers. But it looks quite messy. This is not how invoice numbers typically look in the real world. Now you can left align or right align them. You may have seen this in my previous video. If I add a left arrow here, we get left aligned numbers. That already looks better than before, but it is still not quite what we are looking for. Now let me switch to right alignment. Watch how the numbers shift to the right. The reason they shift right is because Python is inserting a space character. By default, when you specify 4 here, Python adds 4 characters of padding. Even without the right arrow, Python will automatically right align numbers and fill the empty space with space characters right here. But here is something powerful. You can actually fill that gap with a specific character. We can fill it with the character 0. Watch what happens when we run this. The gaps are now filled with zeros. Beautiful. Now that is much closer to what we wanted. But here's an interesting question. What if we want the fill character to be 4 instead of 0? If we try to set that to 4, you will see the problem immediately. Python thinks we want 44 spaces. So how do we fix this? How do we escape that 4 character? Well, if you recall, let me step back. By default, Python aligns numbers to the right. So if I explicitly set right alignment, it has no visible impact. Now, to the left of the arrow, I can specify the fill character I want. Let us use 0 for now. That gives us the same result. But now that the arrow is acting as a separator, I can change the fill character to 4, and now we have a clear separator telling Python what to fill with. And there you go. All invoice numbers are now filled with 4s. It only fills the gaps, of course. As you scroll through, the first entries have 3 4s in front, then 2 4s, then 1, then none at all, because the number itself is already 4 characters long, and we told Python we wanted a total of 4 characters. If I change that to 44, you can really see the effect. Now, there are lots of 4s all the way down the list, but let us keep it sensible. Let us set it to 10 characters total and fill with zeros. And now our numbers look like this. That looks far more professional than a raw, unformatted number. Without this, Python would just pad with empty spaces. I hope the syntax now makes sense. It looks unusual at first, but there is an implicit right arrow that Python inserts automatically. You might wonder whether adding 0 as a fill character works directly. This is a quirk of Python, because 0 has no directional meaning. But the moment you add any non-zero number, Python assumes you want 210 spaces, for example. So using 0 as a fill character works, but if you try another character, such as the plus symbol, you will see an error appear. The correct approach is to include the arrow, and now it works perfectly. The plus symbol is now used as the fill. You can even use a space, and there you go, space as the fill character, a blank space filling the gaps. And if you really want to get creative, you can even apply formatting to the new line character. So now you get the letters I and V, then a new line character, repeated 10 times. But if I change that to 1 and 5, it looks better. Now you can see 5 new line characters. And as you reach the end of the list, there's only 1 new line character. It adapts the spacing dynamically based on the data being processed. Let us switch back to something practical, filling with zeros, padding with zeros. Now, let us also change the alignment. If I flip it to the left-hand side, watch what happens to the numbers. They look like this, which is clearly not the intended result. Always point the arrow in the right direction, otherwise you end up with output like this. To make it even more obvious, let me set that to 20 characters, and you can really see what is happening. The zeros are being added on the wrong side at the end of the number, but we want them before the number. So let us flip the arrow back. And now our string is formatted exactly as we intended. Let us set it back to a more sensible length. And there you go. Let me show you the modern way of using fstrings in Python versus the older string formatting method we have been using. So the difference is, previously what you did was you had a variable over here with a value of 42, and you wanted to print a label saying invoice number 42. What you did was you padded that number with zeros if it was shorter than 5 characters. Since 42 is only 2 characters, you padded it with 3 leading zeros to bring it up to 5 characters total. And you used the .format function to inject the invoice variable from here into the placeholder so that it printed with your standard prefix text inveg bash followed by your formatted number. The modern Python way is to keep your variable exactly as before. But now you embed directly without needing .format. You do not need the .format function at all. Instead, you simply add the letter F at the very beginning of the string. So place an F right here, and then inside your string, use the variable name directly. So invoice goes here, and invoice goes here, with the same formatting you wanted, padded with zeros up to 5 characters if the length is less than 5. In this case, you can see 3 leading zeros. If I change the width to 2, you can see we now get 4 leading zeros, and the 5th character is the actual invoice number itself. So the question is, which approach is better? Well, the fstring syntax is noticeably shorter. You do not need to track the argument positions, because if you had multiple variables and needed another placeholder, this is what that looks like. If you wanted to display something extra, you would add a comma here, then put invoice here, and then you would add something like another argument here, and you can see now you get this output. Now, if you forget to add that second argument and remove it, you get an error because the second placeholder is expecting another value to be passed in through the format function here. The first placeholder maps to the first argument, the second to the second. With fstrings, you do not have to worry about any of that. With an fstring, just add an F at the start, and then within your string, I could easily copy and paste this in. Notice I did not need to manage any positional arguments. I can just reference invoice directly, and it just works. I can add a second invoice variable here, set the width to 25, and put invoice 2 there. I do not have to separate where the value lives from where it is displayed, unlike the old approach where you had to specify each argument position using commas inside the format function. I would definitely choose fstrings. As I have shown before, and you can check my other videos, you still need to understand the .format method too. It is important because you will encounter it frequently in existing Python code. But fstrings are far more common today. The example I showed you earlier, like this inventory table here, the item and the stock, this is now written using an fstring. Notice the F right here. Now, if you remove the F, let us just take it out and show you. Without the F, you just get the raw literal string printed as is. You must have the letter F at the very beginning, then everything works as expected. Notice the letter F here, enabling the formatting to work. If you want to dive deeper into all this syntax, check out my previous full-length video or the short clips I have made on this topic. And you can do powerful things like this with it. With fstrings, you do not have to pre-calculate your values first. Here we have a price variable and a quantity variable. To work out the total cost, normally you would create another variable called total and set it to price multiplied by quantity. That gives you the total. Simple enough, but with fstrings, you do not need that extra step. Inside the curly braces of your fstring, you can write price multiplied by quantity directly, and Python will calculate the total for you, and you get the result right there in the output. Just remember one critical thing. Always include the F at the beginning. The F is essential. Without the F, your string prints out exactly as you typed it, literally. But what you actually want is the magic to happen. You want whatever is inside those curly braces to be treated as live dynamic code that actually executes. So add the F right here, and inside those curly braces, you can write dynamic expressions that calculate the total price inline without needing any extra variable. If you want to learn more about f-strings and string formatting in Python, check out my other videos. Like, comment, and subscribe. I'm on a mission to teach 1 billion people Python around the world. With f-strings, you can execute code directly inside your string. Take a look at this code. We have a variable holding the name James. What we want to do is convert that name to uppercase before printing it. With an f-string, you can embed that logic directly inside the curly braces. And the output will show James in uppercase, because we called the uppercase method on it. This concept keeps going. You can embed full expressions. Here, notice I'm displaying A, displaying B, then the equal sign and the plus sign right here. And then the actual result is calculated here. The output shows 20. That was worked out live inside those curly braces. With f-strings, always remember to include the capital F at the beginning. Because if you forget it, all you get is the exact literal text you typed, with no evaluation at all. For the dynamic code inside those curly braces to actually execute, you must prefix the string with F. Python then evaluates whatever value is in each placeholder. So A is 12, B is 8. Python substitutes those values right in, and anything outside the curly braces is treated as plain text and not evaluated. It just gets displayed exactly as written. So over here, A and B are shown as literals because Python is going to evaluate A, which equals 12, plus B, and add them together. The plus sign inside the curly braces is performing addition, while the plus sign outside is just a character being displayed because it is not inside the curly braces. So it gets evaluated. Now, what if you actually want to display a curly brace itself? You need to escape it. The way to do it is simple. Just double it up. Use 2 curly braces instead of 1, and Python will display it literally. And the same applies on this side. Add 2 curly braces here, and it will appear as a literal brace. Doubling them up is how you escape them. But if you only use 1 curly brace like this, it will not work as expected. The output will look like this, which is not what you intended. What you actually wanted was an odd number of braces to appear. When you only use 1, 2 get paired up, and the remaining one is still evaluated. To get the intended result, add the extra brace here at the end, and you can see it works exactly as expected. Always use double curly braces when you need to display them literally. There's a really powerful debugging technique in Python that most developers do not know about with f-strings. Look at this. We are currently printing variable values using an f-string. An f-string is simply a string prefixed with the letter F, and anything inside the curly braces gets evaluated. The code actually runs. If you remove the F, this is what you get instead. Just the literal words username and points. But here is a really neat trick. Let me add the F back here and also here. When you are debugging code and you're asking yourself, what was the username? What is the value of this variable? What does it actually hold? Oh, it is points. Now you have to go and look up your code. But with an f-string, you can type username followed by an equals sign inside the braces. Watch what just happened. Python automatically displays both the variable name and its value. You can do the same for points too, because you might wonder, what is points? 185? What does that even represent? Just add an equals sign inside the braces, and Python will automatically output both the variable name and the value joined by the equals sign. How good is that? And this only works with f-strings. Just remember, you need the F at the very beginning for any of this to work. Because without the F, it will just print literally like that. Always have the F at the start so that the code inside the braces gets evaluated. Add the F and you will see exactly the output you were after. Now, if you leave out the equals sign, you will, of course, just get the values. This equals sign trick is incredibly useful for debugging, and it will save you a lot of time when tracking down bugs.